Hey everybody, welcome to our next topic. We are going to explore the standard template library this week. This is part one. Our objectives for today's video here is a couple things. We're going to introduce the standard template library at a high level. What is it? We're going to walk through a demo of this skill of how to use other people's code. And finally, we're going to talk about one of the principles behind this, which is interface, using an interface versus the implementation. A pre-quiz. Let's imagine a scenario here. You're working on a software team, and the team asks you to write a class that will be used by a few other people on your team on their respective parts of the code base. So how would you write your class so that it could be easily reused by other members of your team in multiple parts of your code, possibly across multiple files in your program? That's where we're headed. By the end of this video, you should understand how to do this. So first of all, why do we care about this right now? Well, we're about to dive into the standard template library. What that is, this is Wikipedia's formal definition, or at least part of it, is the STL provides a set of common classes for C++, such as containers and associative arrays. This is not like the full definition of the STL. This is kind of a small snippet of it. It's actually much broader than that. But just to give you a taste of what we're talking about, I'm going to focus on these containers and associative arrays very briefly. So at a high level, a container class is a special kind of class that allows us to store data in a specific kind of way. At a high level, to use a metaphor here, let's imagine you have index cards. These are your pieces of data. Well, you can have different data structures to store an index card or a group of index cards. You can have a rubber band, everything is clumped together. You can have this thing like a micro journal, different way to go. Or you can have this thing, which is kind of like these mini folders, index tabs, basically. Each of these has its pros and cons, right? The rubber band is great for insertion. It's really easy to put an index card in there. Doesn't matter where it goes. The micro journal, very hard to insert, probably impossible to insert something unless you, I don't know, probably need glue or something. But on the other hand, it has the advantage of maintaining the ordering of your cards. So this would be great for something like a chronological journal. The one over here, the tabbed version, is great for searching. If you need to find a specific index card, well, you can go to the H section or wherever. So each of these is good for different use cases. Each of these can be thought of a different data structure. I'll briefly talk about associative arrays. These are also known as hash tables or hash maps. Do you remember the frequency counting problems that if you took 231 with me, we did a good number of those. We did one, or you saw one on a previous assignment in online data structures, which was the solution to this poker playing card problem. One of the solutions used this thing called a tally board, where the indexes in the tally board corresponded to card values, right? So for example, card number 3 corresponded to tally board at position 3, or rather the frequency of card number 3 was stored in tally board at index 3. This pattern of storing frequencies of specific values in your data is very common, and using an array can be awkward for this. For example, you might notice here we have this +1 thing going on. That's because arrays are 0 index, so the actual indexes go from 0 to 12. However, our card values go from 1 to 13. So to solve that, in this case, what we did was we just added 1 to the size of our array. So there's actually 14 elements in our array, index 0 through 13, but we're just not using the 0th index. It's like wasted space, I guess. So it's a little awkward. And it'll get more awkward if, I mean, imagine if the card values were, I don't know, 100 to 112, right? Then you'd have to have some other, are you going to do plus 100? I mean, you'd have to think through that more carefully. Anyway, there is a much better data structure that is designed for exactly this kind of a situation. And these are called associative arrays or hash tables or hash maps. I'm going to show one quick example, but before I do, one caveat, don't worry about understanding this code yet. I'm just showing you a taste of what's possible. So here we have this thing. We include map from the STL, standard template library. We declare one here, and we use it here. So we're inserting these value pairs. These are keys. This is a key. This is a value. This is a key. This is a value. So hash table or hash map is characterized by these, a bunch of key value pairs. And here you're basically saying, okay, I'm going to have a key of 1 with a value of 40. So you can use something like this for a tally board. You can say, okay, the number 1 appears 40 times, the number 2 appears 30 times, and so on. All right, so again, don't worry about understanding this too much yet. We will try to cover hash tables before the end of this data structures bootcamp. If not, you'll see it in 238 and you'll learn it more carefully there. So what's the point of this? Why am I showing you this stuff? The point is that some nice folks wrote a lot of useful classes and functions that programmers like us all over the world can reuse over and over again in our code. And the standard template library, again, has much, much more. This is just a small snippet of it. This is huge. The ability to reuse other people's code is one of the most impactful things you can do with your programs. You can basically stand on the shoulders of giants who've written all sorts of cool things, and so you can gain the benefit of all the work they did if you know how to reuse people's code. So before we get into all of this, we're going to practice this skill of reusing code, and we're going to write our own class that we could reuse or other people can reuse again and again. So let's revisit our scenario here. So going back to our pre-quiz. You're on a software team. The team wants you to write a class that'll be used by a few other people on your team. Specifically, their code base involves working with circles. And the various people on your team, they find themselves making mistakes. They confuse perimeter with area, or maybe they get the formula wrong. So they're asking you, hey, can you just write a circle class that has a get area and a get perimeter method? Oops, I should say methods. Which can be reused by other members of your team. That's what we're going to do. So as an example, this is a pretty silly, trivial example, but just to illustrate one possibility here. Let's suppose you have these two programs. So let's imagine the people on your team are creating games that involve circles. Okay, so here, this is a guessing game. They enter the radius, it computes the area, and then it asks you to guess the area. And if you're close, then it says nice guess. Otherwise, not accurate enough. I'll just run through this one once. So radius of 5. I'm going to guess that it's around 75. And I guess I'm pretty close. Okay. Let me try a guess that's way off. Oh, 5, and then 90. Okay, sorry, not accurate enough. So if I'm within 3, it says nice guess. That's one game. Another game is going to be this. All right. This is a more complex program, and this is a solution to a Caddis problem that you might have done if you took 231 with me. We did this problem, racing around the alphabet. Okay. And here is a solution. And you'll notice that it declares pi and it uses some circle operations here. Okay. So don't worry about understanding all the code here. The important thing is for you to recognize that these two different programs make use of circle functions. And so our goal is to somehow create a circle class that can be reused by both of these programs, which are in two different files. Here are our steps. We're going to demo this. We're going to create a circle class. Let's do that first. Okay, so let's go into the first one. And I do have my circle class pasted somewhere. I'm just going to go here and copy it. There's a circle class. It has a private variable, radius. It has a public constructor, which takes a single parameter, which is a radius. It has a public method called getArea and a public method called getPerimeter and a constant double pi. Okay, so we're just making pi a public variable in the class in case other people want to use it. We're declaring it as a const to enforce that this should not be changed by anybody. So let's go ahead and implement these functions. Circle, circle. Oh, it takes a radius. And we're going to set our private variable equal to that, right? And let's implement our getArea function. It returns a double. It's got to be circle. Return radius times pi. Oops. GetArea. Radius times radius. It's pi r squared, right? Okay, let's just test this out. We wrote some code. Let's test it to make sure that it works. So before I write the perimeter function. So how do I do that? Let me just comment this out for the time being so it doesn't distract us. I'm going to, first of all, declare my circle instance here. I'm going to make a instance of my circle class and pass in the radius. And then here, I don't actually need this anymore because our circle class takes care of that. And here, I'm going to do myCircle.getArea. Let's run this and see if it works. Nope. Oh, I missed something. Here. Okay. Oh, all right. That's because I tried to do some prep work by having my code written ahead of time, and it's complaining about this. I'm going to delete this for the time being. Let's see, how can I do that? Delete it. Ignore that. We'll get to those files in a moment. Let's see if it runs now. There it is. Okay. Enter radius of circle, 5. Guess the area, 75. Oh, not accurate enough, huh? Let's try it again. I think it was 78, right? Let's try 577. Okay, that works. So now let's implement the perimeter. Double circle get perimeter. This is going to return pi times radius times 2. Let's run it, does it still work? Yeah, looks fine. All right. So we've created our class. One challenge here is, remember we have two programs. So this program here, this solution to the caddis problem, how is this going to make use of this class that we just wrote? Well, in its current form, it can't. So the next step is we're going to create a separate file, actually two files, that will help us define our class externally. We're going to see two kinds of files here. One is a header file, one is a CPP file. Okay, those are the files I was just playing with here, and now we'll go over what those mean. The header file, circle.h, is going to have our class definition and all of the function declarations, the method declarations. So I'm going to copy this and put it into circle.h. Circle.cpp is going to have all of the method definitions here. So remember, the difference between a function or method in this case, declaration versus definition, the declaration tells you the name of the method, the inputs, and the outputs. So in other words, the header file kind of tells you what's in the class. What can this class do? The CPP file gives you the implementation. This kind of determines how those methods are implemented. Okay, and we'll see why it's, well, we'll see shortly why the header file is so useful, and the CPP file, it turns out, doesn't need to be, it doesn't need to be as visible as a header file. So let's take a look at this now. Does this work? No, because this main.cpp file needs to somehow include the circle class. We're going to take a look at this kind of syntax, and we're going to use it to include our circle class. So we're going to include circle.h. Notice the quotes here instead of the brackets, the caret signs. The quotes indicate that this, circle. The quotes tell the compiler that this circle.h file is located in the same directory as main.cpp, which we see here, right? Circle.h is in the same directory as main.cpp. Okay. So now if we run this, I think it will work. Let's try it. Nope. Let's see. Circle does not name a type. Oh, okay, right. So this main file needs to include circle.h. There's another file that also needs to include it, which is circle.cpp. This thing, circle, is not defined anywhere in this file. So this also has to include circle.h. Let's try that. Okay, there you go. That works. Let's try it. 577. Great. So we've just included our own class. And by the way, I'm noticing this one can be deleted because we have pi defined somewhere else. There we go. Is it still run? Yeah. Okay. Now we're in a position where we could reuse the circle class in other parts of the code, in other programs. But before we do that, let's look at one nuance here. Notice how the circle.h is being included in multiple places. It's included here in main.cpp. It's also included here in circle.cpp. It turns out this can create problems. If you imagine you have a code base with, I mean, here we have 3 files, but if you have a code base with 100 files, and maybe all 100 files include circle.h, well, then the same code is going to be included over and over and over again. So in order to prevent that from happening, we're going to use this special syntax Let's go over this. This is called a preprocessor directive. We've seen these before. For example, here, this is the preprocessor directive as well. It tells the compiler, hey, we need this IOStream library, so include it. This here is also a preprocessor directive, and it's telling the compiler, hey, this chunk of code here, we're going to give it a name. We're going to call it class_h. If that hasn't been defined yet, then define it like this. And then this kind of ends the if statement here. So don't worry about understanding this too much. At a high level, be aware that, first of all, this syntax exists, and be aware of the problem that it helps us solve. This helps us solve the problem of the same class being redefined over and over and over again if it's included in multiple places in your code base. Okay, so now we are at a place where we can reuse this class in other programs. And so going back to this program here, this is our caddis problem. I've already set this up so that the class is here in the same directory. And we can refactor this program here to use our class. So in the same way, we want to do include circle.h. And we can delete this. Pi, we don't need that anymore. This stuff is going to change here. So we're going to make another circle instance, my circle equals circle. And we have the diameter, but let's suppose I don't remember, can I pass in the diameter? Well, I can look at the header file, and it tells me exactly what I need to pass in. Well, no, it expects a radius. Okay, so let's go back here, and I have to somehow pass in the radius. I can just pass in diameter divided by 2. There you go. Now, this circumference thing. I don't want to be calculating my circumference like this. The circle class should handle this, right? So I'm going to delete that. And how do I use the perimeter method? Well, I can go to the header file and look. Oh, look, it has a get perimeter method, and it returns a double. Okay, that sounds about right. So let's type my circle.getPerimeter. And there you go, that should work. Notice that I was able to use the circle class just by looking at the header file. I didn't need to know how the getParameter method works. I don't need to know what it does. All I need to know is, what is it called? What's the name? Do I need to pass it any arguments? And what does it give me back? It gives me a double. Those 3 pieces of information told me everything I needed to know in order to use it. Let's see if it actually works. All right, there you go. Let's say 2 aphorisms. Hurrah. That took 14 seconds to run around the circle and get all the alphabet numbers based on the caddis problem. And then let's try another one. Woot. It took 11 seconds. Great, so it looks like it still works. All right. So we walked through this step. We separated the class into header and CPP files. Now, one note about this. We included the .h file. We did not include the .cpp file. In general, never include the .cpp file. All right, so you would not do something like this. You include the .h file. Okay, so now you've seen a demo of how you would create a class that is reusable by multiple people writing different programs. One of the principles I want to highlight here is this idea of using the interface versus the implementation. The header file gives you all the information that you need in order to use a Circle class, right? If you remember, if we forgot what a method did, we could just look it up in the .h file. If we didn't know anything about the class, we could just open the .h file and see everything that the class does. Specifically, this public section tells me, as a consumer of this class, everything I could possibly do with this class. Not once do I need to go into the CPP file to see exactly what it's doing. I didn't need to do that. So, in other words, we didn't need to look at the CPP file, the implementation of all the methods. The header file serves as an instruction manual for using the class. In other words, you could say it's an interface. It's some outside person, the header file tells me everything I need to know in order to interact with this class. Okay, so there you go. This is your primer on what it takes to reuse other people's code and write code yourself that other people could reuse.